Hello, students. This is Mr. Campbell again with day 9 of our Unit 2. Just kind of going to look here and we can see some announcements with regards to the Unit 2 Quiz 1. That is going to be due, as you guys know, this Friday. So make sure you complete those 15 multiple choice questions for a grade. Make sure your notes are fully up to date for that. All your stuff is up to date for those accordingly as we go along, because the quarter ends, as we know, around the 20th or 23rd, I believe, one of those dates. So within the next 2 weeks, we need to make sure we get our assignments up to date. We get our everything up to date as we move along to get the highest grade possible. Outside of that, guys, again, continue keeping your notes with our video lessons. Continue to, I will be posting workbook pages soon, and I will be posting a new vocab soon. So be ready and on the lookout for that. We have our 3 Go Blue questions, guys, on page 12. Number 1, what is slab pull and what is the main cause of tectonic plate movement? Number 2, what are the 3 causes of Earth's magnetic field? And number 3, why does Venus not have a magnetic field? Go ahead and pause the video, answer those on your own, write those on your own, and we will share once you guys are ready. Moving on, number 1, guys, what is slab pull? Well, it's when one tectonic plate is going below another. This is Earth's way of recycling the crust. It's not going to just have the plates bumping into each other side to side each day, okay, bumping into each other over time. You're going to have some that kind of envelop the other one, and they're going to go down in the hot mantle. And what happens when it goes inside the hot mantle? It's going to melt and get recycled. And on the other side, we're going to get some new crust. We'll talk about that in a minute. Okay. So again, where it melts and creates ocean trenches. That's super important, guys. When one plate goes below another, again, this should be answered on our Go Blue, guys. When one plate goes below another, part of that crust gets dragged down, and it's going to, again, as it gets dragged down, it's going to create the deepest parts of our ocean. Again, we call those ocean trenches. Moving on to number 2, I've got a little video clip for that, talking about what moves the plates, what causes tectonic plate movement. Let's go and take a look here. I'd like you guys to watch all of this for a good recap over some of this tectonic plate stuff. Let's kind of watch some of it on our own here as well, a little sample.
And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's.
And you guys just heard the answer right there. Again, you should watch the rest on your own. It's going to be the what currents in the mantle? Hopefully you guys know at this point, the convection currents. The convection currents are what are flowing those plates, flowing our crust, just like the conveyor belt at the grocery store, just like the escalator at the store, right? There's a belt moving those things about. There's also that belt flowing about, moving our continents, moving our plates, right? Okay, moving on to question number 2. Super, super important, guys. One of the most important Go Blues I've seen in a while. What are the 3 causes of Earth's magnetic field? Yes, the force field, the shield surrounding our planet, protecting our water, protecting our life from the sun's deadly radiation, okay? Because we can get some radiation, but too much of it would be terrible for our planet. But what's causing that protection? Well, we've got the iron inner core. Yes, the Earth is a ball of dirt and water and magma, but at the core, it's actually a super hot pressurized metal ball, okay? That's the main cause. Secondly, convection of the liquid outer core. You've got flowing energy, flowing parts of that outer core. And then thirdly, guys, the Earth, unlike a lot of planets, is spinning very fast. Just like a hamster wheel producing power, the spin of the Earth helps conduct that static metal energy from that metal core. Okay, so those are your 3. You've got it, 3 main causes of the magnetic shield surrounding our planet. It's why we have one and Mars does not. Okay, Mars's core was not strong enough to keep a magnetic shield. It did once have a magnetic shield. It did once have water, but not anymore because it doesn't have the strong enough metal. Now, the third question here goes into Venus. Venus does have the same core. It does have all that iron. But what does it do differently? Why does it have the magnetic shield still? Why is it so different? Keep in mind, we're second from the sun. We're third from the sun. Venus is second closest to the sun. Let's go and check it out. Really good video here. I really want you guys to watch all of this video. It's only 1 minute, 50 seconds long. I just think it really sums up this question for us.
but not on Venus. Why? Let's back up. Venus is sometimes called Earth's sister planet. Their size is similar, and Venus has around 81% of Earth's mass. Both planets have a central core, a molten mantle, and a crust. They share the same area of our solar system, with Venus being the closest planet to Earth. But did you know that a year on Venus is shorter than a day on Venus? Let's figure out why. Our Earth calendar system is based on the rotation of our planet. What we call a day is Earth rotating once around its axis.
Earth's got a fast spin.
A year is Earth orbiting once around the Sun. But Venus is different. Venus rotates opposite direction of Earth. In fact, Venus rotates in the opposite direction of all of the planets. Only Uranus joins Venus in rotating clockwise.
Venus. What's the big difference? Well, guys, Venus, it rotates too slow. Venus rotation is way too slow, way too slow. Again, one day on Venus is 240 days compared to Earth, right? So it takes 240 Earth days just for Venus to spin on its axis once. Okay, Earth is spinning way faster. Venus can't spin fast enough for it to produce that shield. Okay, so again, for number 3, it's a very short answer. Venus rotation is too slow. In fact, Venus spins backwards compared to Earth, and we think that's because an asteroid hit it millions or upon billions of years ago, potentially. Okay, so let's go ahead and move on. Nothing new there. I mean, 12 through 13 plate tectonics figures. We're about to finish that right now. We talked about slab pole. Again, don't write any of this stuff, guys. All I want you to write right here is on page 10. Page 10 or 11, probably need page 11 or 12, wherever there's space. I need you to know this concept of ridge push. Ridge push is the opposite of slab pole. Again, write this down, guys. Ridge push, ridge push. We talked about with slab pole, the plate is being pulled down, it's melting and being recycled. Well, what's happened? And that forms, remember, guys, what does that form? Ocean trenches, okay? Well, what's happening on the other side of those plates? Well, on the other side of those plates, the plates are being pulled apart. They're being torn apart, okay? So slab pole, going together, ridge push, pulling apart. And when crust gets pulled apart, what comes out of the middle? You've got it, molten rock and magma. That's gonna form new crust. So slab pole, getting rid of old crust, melting old crust, ridge push, okay? Gonna be bringing up the new crust, the molten rock that goes in the ocean and then cools down and hardens, okay? So just put this right here, what's in yellow. Lithosphere acts like conveyor belt, recycles itself, new crust pushes the old crust out, creates not ocean trenches, instead we've got ocean ridges. And you guys can see a great example right here on the GIF at the bottom. So the plate gets pulled apart, pushed apart, new crust comes up, new magma comes up, and sometimes we get volcanic mountains from this, guys. We get island chains in the Pacific Ocean. Great example would be the Hawaiian Islands, right? So go ahead and make sure you write ridge push down. Okay, let's go ahead and take a break here with 2 practice questions, and then one last thing I want you guys to write down on that page. Our first question of today, which we just went over in our Go Loose, hopefully you guys know it by heart, know it by memory. Which helps conduct, keyword conduction, Earth's magnetic field the most? I think we did this maybe yesterday, but I want to make sure you know it for now. Okay, is it A, convection currents, B, core rotation, C, nickel, or D, iron? Again, what's the inner core? What's the most important metal in the inner core? It's going to be, guys, pause the video, think about it. D, iron, guys. Again, just so we know by memory, super important to know. Iron. Okay. Last thing I want us to know, guys, is go ahead and write down technology. I just want you guys to know how technology is going to impact. Okay. So how has studying the magnetic field helped us improve technology? I'll go ahead and just write that down, put that in yellow. Okay. And we've got to answer. I've got some videos here. By studying magnetic science, what does it help us teach us and apply in the real world? Okay. Well, think about this. Before we had cell phones, before we had satellites, before we had GPS, okay, what did people use to know north, south, east from west? Okay. They used compasses. Okay, and if you didn't know, compasses have magnets inside them that cause the little spindle to move to show north, south, east, west. That's influenced by our magnetic field. Not only that, guys, we've got batteries. Batteries are made of what metal? Iron, conducting that same electric current. So batteries and such. I have some videos here. Let's take a little break here and see how compasses work for one split second. Again, I will be posting this to Canvas as well for you guys to watch fully. Oh, that's the wrong video. 1 second. Wrong video. Where is it out here? I found it. It was hidden. Oh, I didn't find it. It's just not my day, guys. It's not my day. Not my day today, guys. Okay. Where is it at? Where is it at? Compasses. Compasses. How do I found it. Finally, the last one, right? Check it out.
Compasses have helped lost souls find their way home for more than 2,000 years. But how does a little metal needle actually know which way is north?
It's got a magnet inside.
In a sense, the Earth itself is a giant magnet. It has a North Pole and a South Pole, and those poles can interact with other magnets in the same way that the magnets on your refrigerator can. Opposite poles attract, while like poles repel. The needle in your compass is also a tiny magnet, made from magnetic rock like iron and suspended in liquid so that it can swivel freely.
All right, guys, so again, you can watch the rest of that on your own. If I show all these videos on my channel, on my YouTube, YouTube will get mad at me for that. So again, I need you guys to watch that on your own. But again, compasses are made of magnets. And another cool thing, here's the rest of it, guys. We have, so not only just compasses for navigation, we've got computers, we've got batteries, electricity, microchips. Again, a lot of the components of your computer, the components of your cell phone has some magnetic technology inside of it. Pretty cool stuff there. So go ahead and make sure you jot those down. I had another cool video that if you look up, it talks about magnetic micro robots. They're using magnetic technology to use robots, little micro robots that can go inside of you like for like small tissue surgery or maybe to brush your teeth. Incredible stuff that may be used later in our lives. Incredible things. Technology never ceases to advance and improve. Okay, so make sure you write down just improve those categories. Last thing of the day, guys. Last thing of the day is our last question. Again, just ignore that. We already did that for a Go Blue. Steam from water in a cooking pan heats up my hands. What type of heat transfer is this? So we're not talking about the heat transferring from the pan to the stove. I'm talking about the steam here, the steam, the molecules. Is it A, magnetism, B, radiation, C, conduction, or D, convection? Pause the video, think about it, see if you get it right on your own. Continuing, guys, steam, we're talking about molecules. It's going to be letter D, guys. Convection. Convection always has to do with the movement of molecules. That is convection. That concludes our lesson today, students. We've got, again, our online quiz we need to finish before the week's over. Get your notebooks up to date. We'll have a new vocab soon, and I'll have a workbook activity coming up as well before the quarter ends here in 2 weeks. If you have any questions, I got a couple Canvas messages I've got to get back to hopefully soon, and we'll get you again within 24 hours answer on those and taken care of. Again, Mr. Campbell signing out. I will see you guys with another video lesson tomorrow.